Hi everybody! Today we are going to solve a system with methods that have been explained in the previous videos. As usual, you will find the links to all the videos that you may need to watch in the description below. In order to solve this system, we are going to compute its augmented matrix, where the entries are simply the coefficients of the three equations of the system, as you can easily check. Just remember that if in some equation of the system you don't see a variable, that simply means that its coefficient is equal to 0. This happens, for example, in equation 2 for the variables x and z, but also in the third equation for the variable y. This system is a particular system because it has no solutions at all. We cannot predict it right now, but it will flow from the calculations we do from here on out. We will solve this system with Gaussian elimination. You will see that we won't even need to go until the end of the process, because the solution of this system will become clear before we can even reach a row-echelon model for our augmented matrix. The first row starts with the number 1. Then we do not need to work on it. Instead, we would like to replace this -2 from row 2 with the number 1 in order to create a new corner for our stair-step matrix. In order to do this, we notice that we just need to divide the second row by -2. Indeed, if we divide the second row by -2, we obtain the following. Let's work step by step. 0 divided by -2 is equal to 0. -2 divided by -2 is equal to 1, which is exactly what we wanted. 0 divided by -2 is 0. And finally, 4 divided by -2 is equal to -2. And this is the final result as for step 1. Now we can continue with the second step, where, of course, the starting point is the last matrix that we obtained in the previous step. So this matrix that you see now on the screen is nothing but the last matrix that we just obtained. Here we notice that we almost have a row-echelon matrix. Indeed, we have our corner equal to 1 in the first row, our corner equal to 1 in the second row, but we would like to have the element 0 here in the third row. So let's work on this row. In order to replace the number 1 with the number 0 in the third row, we simply do the following operation. Row 3 minus row 1, R3 minus R1. Let's go on step by step, column after column. 1 minus 1 gives us exactly 0, which is exactly what we wanted. Then we go on with the second column, where 0 minus 3 is equal to -3. Then third column, y minus 1 gives us 0. And finally, 0 minus -1 is equal to 1. And this is the whole matrix that we obtain after the second step. We can now move to the third and last step. In order to obtain a row-echelon matrix, we notice that here we have the number -3, where instead we would like to have the number 0 again. Then we work on the third row again, doing the following operation. Row 3 plus 3 row 2. This will allow us to eliminate the element -3. Let's see how step by step. From the first column, we obtained 0 plus 0, which is equal to 0, of course. From the second column, we obtain -3 plus 3 times 1, which is equal to 0, exactly as expected. Then from the third column, we have 0 plus 0 again, which is equal to 0. And finally, 1 plus 3 times -2, which is equal to -5. And this is the final result. Please notice that this matrix is not a row-echelon matrix, because in the third row, instead of 1 here, we have the element -5. That means that we would have to divide the whole third row by -5. But let's look at the matrix that we obtained. Is it really necessary to go any further? Do we really need to complete the Gaussian elimination method? Actually, no, as we can see from the following calculations. Let's go back to our problem, the solution of the system. We transform the last matrix into a linear system of 3 equations. And we know that the solutions of this new system will be exactly the same as the solution of the given one. This is what Gaussian elimination does. This is why we worked so hard until now. But from the third equation of the system, we see something really crazy. We see that 0 is equal to -5. Is that even possible? Of course not. That means that the whole system is simply not possible, or that we have no solution at all. We can actually understand this from the last row of the augmented matrix, as all the elements but the last one are equal to 0. And then you know that 0 will be the coefficient of x, the second 0 will be the coefficient of y, and the third 0 will be the coefficient of z. That means that from this augmented matrix, necessarily we obtain an equation where to the left we have 0, and to the right we have this green number, which is different from 0 in this case. So we cannot have something which is equal to 0 equal to something which is different from 0. That is why the system is impossible, or we have no solutions. In conclusion, working on the equations of our system through its augmented matrix, we reached the impossible claim that 0 is equal to -5. That led us to the only possible conclusion, that the system has no solutions. We can also say that the set of solutions is empty. And this is actually the end of the video. Thank you very much for watching. Don't forget to like, comment, and subscribe. Thank you very much again. Bye.